Hi guys, I gave you some problems on page 375 to reinforce what we talked about in class the other day, which culminated in the very end in using the periodic table to do electron configuration. And so those problems were problems 45, 46, 47, 49, and 51. Now, these are not assigned to you for a grade. These are just for you to practice to make sure that you understand the content and understand, you know, how to apply your knowledge that you learn in class. You still are responsible for your homework on mastering chemistry. So I'm going to do a few of the lettered problems within each one. Probably won't do them all. So just to get you started and make sure that you're on the right track in understanding how conceptually each one of those problems is worked. So looking at number 45, number 45 asks us to use the periodic table to write an electron configuration for each element that's listed below. It asks us to represent the core electrons with the symbol of the previous noble gas in brackets. So basically it wants us to use the bracket notation and write the electron configuration for each element. So the first one that it gave us is phosphorus. So what the first thing we want to do is locate phosphorus on the periodic table. And we see it's located here. And it contains, has an atomic number of 15. That means it has 15 electrons. And in order to use the periodic table and bracket notation to express the electron configuration, what we need to do is identify the noble gas that precedes phosphorus. And so when we do that, the noble gas in the period above phosphorus is neon. We then need to look and find where phosphorus lies, which block it lies in. So it's in the P block, and the S block has already been filled in the same period before the P block. So that's all we need to do. So we would write down our neon core, neon here. We write down here that we know that the S block is filled, and it is the S block in period 3. So period 3, S block has 2 electrons. And then we go on across to the P block. The P block in row 3, we can count over to phosphorus as 1, 2, 3. So the P block has, the P orbital has 3 electrons. So basically the electron notation, electron configuration for phosphorus is neon 3s2, 3p3. And we can check that by counting electrons. There's 10 here, there's 2 here, there's 3 here. That equals 15, which is the correct atomic number for phosphorus. Okay, it checks out. So, of course, you can pause the video at any point in time if I'm going too fast or anything like that. I'm going to go ahead and just not do any pauses. I'm going to go ahead and go through because you have that ability to pause, fast forward, or whatever you need to do, back up, rewind, etc. I don't know why this is not erasing. Okay, the next one is germanium. So germanium on the periodic table is located right here. And so the first thing we do, we can look at what is the preceding noble gas, and that is argon. We see that germanium lies in the P block. We also see that germanium lies in row 4. So we see that the 4s electrons are filled. And we also see that all of the 3d electrons must be filled as well. The reason I said 3d electrons, we know that when we start talking about the transition metals, when we fill the d block, starting with row 4, the 4s electrons fill, and then the 3d orbitals fill. So although this is row 4, these electrons are in the d orbital of energy level 3. Remember, if we refer back to your diagram, it all corresponds to that filling up principle. This is a higher energy level here. Okay, so just putting it all together, this is in row 4, but in row 4, the d electrons that fill are 3d electrons. And it would be the same if we were looking at row 5. If we were looking at row 5, the 5s electrons would fill, and then the 4d electrons would fill next. Okay, but anyway, we're using the periodic table to write this configuration. So we start with the argon core that we've identified. We follow it around to here, and we see that we have 4, and then these are S, S2, and then here we have our 3D, and the whole D block is filled. So that's 10 electrons, 3D10. Now we go back up to energy level 4, and we've got 1, 2 p electrons. Alrighty. And if you add that up, argon has 18, so this is 20, this is 30, and this is 32. So that's a total of 32 electrons, and it corresponds to the correct atomic number for germanium. Using a periodic table is a little bit tricky at first, but all you have to remember is you just look at the period number, the block it's in. These are the S blocks. These are the P blocks. These are the D blocks. When you get to the D blocks, you remember that to fill the electrons in the D blocks, you just subtract 1 from the highest, from the period number on the left-hand side. Okay, so that's the electron configuration for germanium. So now the next one is zirconium. And zirconium will have the same principle that germanium had in terms of filling D block electrons. So that's why I'm going to do this one for you. Okay, zirconium is here in the periodic table. Okay, and so we need to identify the preceding noble gas, and that's here, and that's krypton. Then we need to identify which shells which shell the remaining electrons are in. Okay, so I'm just trying to make sure I can. Okay, I think that works. All right. So krypton core, KR. We come over here and we look at the period number. The period number is 5. In period number 5, we fill the S block with 2 electrons. And then as we go from the S block into this territory, this is D block territory. So that means we need to go down number And this is going to be 4, and these are the D blocks. So then you have 1, 2, 4, D, 2. When you check it out, that's 36 electrons here in krypton. Then you got 2 in your s orbital and 2 in your d orbital. So that is a total of 40 electrons, which is the correct atomic number for zirconium. Okay, the other problem that you were asked to do is iodine, and I'm not going to go through that one. I think that now you should be able to do iodine on your own, but you're simply going to look for the preceding noble gas configuration and then fill your electrons based on what block the atom is in. I guess I will do it. I'll do iodine for you. Here you go. Here's iodine. Here's your preceding noble gas. Iodine is the P block. And before the P block filled, you have the S block that was filled. So helium core, looking at the period number, which is 2. The S block is full, so 2s2. And now these are the two P's. So the P block is not full, so you count over 1, 2, 3, 4, 5. And so your P block has 5 electrons. Okay, to check, helium has a total of 2 electrons. There's 2 here, and then there's 5 here. So that's A, which is the correct atomic number for iodine. Okay, so that's it for number 45. I'm going to do a couple of the ones off of number 46. Let me erase this first. All right, so for number 46, it asks us to use the periodic table to determine the correct element corresponding to each electron configuration that it lists. Okay, so I'm just going to do 2 of them. The first one is the argon core, 4s2, 3d10, 4p6. So all we have to do for these is go based on what block we know it's in. So we know we have the argon core, and that means after that we came down here to the 4s2, that's filled. Then we go all the way across the 3d block. It's filled with 10 electrons. Remember, D has 10 electrons. And then we go all the way over here and we count that there are 6 electrons in the P block. And that puts us here. Right here. We started with the argon core. Then we went up to the next row. And we knew we were guided by the configuration that there are 2 electrons here. So we know that that shell is filled. that orbital is filled. Then we were told that there's 10 in the D block. So we know if there's 10 in the D block, that means that the entire D block is full. And then if there's 6 in the 4p6. So 1, 2, oh, I'm sorry. I'm just, my vision just caught up with me here. Let's see, let me count backwards. All right. So that's the D block right there. I drew a little bit too far over. Let me go back in here to make sure I have that. Okay, so this is the P block here, and the D block is right here. So we count over. In the P block, we have 1, 2, 3, 4, 5, 6, and that falls on Krypton. Okay, let's do one more. Let's do letter C. Letter C is 4, 5s2, 4, 10. Uh-oh. 4, 10, and then 5p2. All right. So once again, starting with the Krypton core, we start here, and then we know we go to the next row here. We know that from the configuration that 5s is filled with 2 electrons. We see that 4d is also filled, and this is 4d here. All of these are 4d. They each hold 1 electron. I'm sorry, each d orbital can hold 2 electrons. So it could be a total of 10 electrons total across the D block. And then we count over into the P block. 1, 2. So the atom is SN or 10. All right. So quickly, I'm going to go through 47. 47 asks us to use the periodic table to determine each quantity. And it lists a series of different things that it's asking us for from looking at the periodic table. The first one is the number of 2s electrons in lithium. Okay, so we look at lithium. We see that lithium is in group 2, row 2. And being in row 2, it falls in group 1. And counting over as well shows us that we have 1 electron because we don't make it over here to the block that has the 2 electrons. So we just have 1 2s electron in lithium. Corresponds to group 1, and we can also rationalize that it is in the S block, and only one um, of the boxes in the S block have been filled up. So it has 1, 2 S electrons. The next one asks us to tell us the number of 3D electrons in copper. So we simply find copper. We see that it is in row 4. So that means that the D electrons that we are referring to are D electrons. I'm sorry, are 3D electrons. So since it's in row 4, it's in the D block, but these are 3D electrons in this D block. So we count over, starting at the D block. This is 3D here. We start, and this is 4D here. This is 5D here for future reference, etc. Okay, so we count over 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 3D electrons. Okay, and you do the other ones the same way. Now, moving on to 49. 49 asks us to name an element in the 4th period of the periodic table that has, and it lists the different things that it wants us to name. Okay, and the first one is 5 valence electrons. So it asks us to look at the 4th row. So that's this row here. And name a element that has 5 valence electrons. So the outer shell in this row, we got our D's here, but these are inner shell electrons. These are 3D electrons, remember? So the valence electrons are going to be those that are in the higher shell, which is 4, and that's the ones that are here, and they skip completely over the D block and come over here. Okay, so to count the number of valence electrons in a to find 5 valence electrons, we just come over in row 4 in the boxes that correspond with energy level 4. So this is 1, this is 2, this is 3, this is 4. So this is the 1. I'm sorry, and this is 5. It wanted 5 and it was 4. Okay. So corresponding to 5 electrons valence on row 4. Okay. So the next question on number 49. 49C asks us to look at row 4. We're still looking at row 4 for all of these questions in 49. Looking at row 4, it asks us to name the element that corresponds to having 3 4p electrons. Oh, I'm sorry. That was from number 50. I'm sorry. That's the incorrect question. It asks us to look at row 4 and find the element that has 3 3D electrons. Okay. That's this row. And so we want to look at where there are 3D electrons. So this little block right here corresponds to the 3D block, remember? And so now we just kind of want to figure out which one of those elements corresponds to 3 of them. So that's 1, 2, 3. So it's going to be this one, and that's vanadium. And we'll do the other ones exactly the same way. I'm going to do the next one for you, just to make sure we're definitely on the same page. The next one is C, and it asks us to look at row 4 still and find the element that has 4p electrons. Okay, and we're in row 4 here. This is the S block. This is the P block. So counting the number of electrons in P up until we get to 4. And that's going to be 1, 2, 3, 4. And it's going to land right here. Let me look at that element in there. I can't see it. Yeah, selenium. So that equals. Okay, so the other one, you can do that one on your own. The very last one is number 51. We got a clean periodic table here. Number 51 says, determine the number of valence electrons in each element. And we're simply going to use the periodic table to do that. This is going to be one that should be pretty easy. So determine the number of valence electrons in each element by looking at the periodic table. Okay, so the first one is barium. So barium is, let's see it. It should be somewhere over in here. Yes. Barium is right here. Barium is in the group 6. Is on the 6s block. Is the highest filled orbital there. So therefore, since the highest filled orbital is 4s, it happens to be 4s2 block, then the number of valence electrons in barium are 1, 2. All right, so same thing for cesium, Cs. I'm going to erase this. Let's find cesium on the periodic table. Okay. Cesium is here. Cesium is in the S block here. He's in row 6. He corresponds to the block that has 1 electron. So cesium has one electron in its valence shell. And how about nickel? So there's this nickel. Let me write this down too. All right, so now for nickel. Nickel is right here on the periodic table. It is in row 4, or in terms of order of filling, it's further to the right in this direction on row 4. But these are orbitals. These are the d orbitals that are in the third energy level. So those are 3 d orbitals. So higher in energy are the 4 s orbitals here that are valence shell electrons. So remember, we don't go in terms of order of filling when we are determining the number of valence shell electrons. We look at the electrons that are actually in the highest energy level. So the number of electrons occupied by the highest energy level here are 2. There are 2 valence electrons in nickel. So the very last one is sulfur. Sulfur here, you've got sulfur falling over here in the P block. These are the 3 s electrons here. These are the 3 p electrons here. So 3 is the highest occupied energy level. And so therefore, all of these electrons are going to be in the third energy level, are going to be valence electrons. Okay. Okay, so there's 6 valence electrons in sulfur. Yeah. So that concludes the the problems and looking at the solutions to the problems, but understand that these problems were specifically using the periodic table to find this information out. It would have been probably more straightforward and more understandable. You probably understand it more clearly. You could also use the electron configuration and the orbital diagram notations in order to answer these questions. But my goal here in this tutorial was to make sure that you understood what we did in the last class, which is how you can use the periodic table to find out this information. So to challenge yourself, to make sure that you're completely coherent in everything that we've learned to do thus far, why don't you go back and for those that you can use the electron configuration or orbital diagram notation to figure out, see if you can do it and get the same answer. Okay, so that concludes the tutorial for the problems that I assigned on September 1st.